All right, let's talk about one of the coolest ideas out there, time travel. But forget all the spinning dials and flashy lights you've seen in the movies. Today, we're diving into a speculative blueprint, one that's actually inspired by real physics that completely rethinks how we could navigate the fourth dimension.
And here it is, the big idea that changes everything. Stop thinking about a vehicle that moves through time. We're talking about something way more elegant, a way to just skip between coordinates on the map of space-time itself. It's a huge shift in thinking, and it all starts with a technology that's already making its way from sci-fi to actual science fact.
So before we can even begin to sketch out our time gate, we all need to get on the same page about what teleportation really is. Because trust me, the real-world physics is somehow even weirder and more fascinating than what Hollywood comes up with.
I bet I know what you're thinking. You know the scene, right? A shimmering light, a person dissolving into a cloud of particles, and then, poof, they reassemble somewhere else in an instant. That's the classic trope. But in the quantum world, it doesn't quite work like that. Here's the difference you've got to get. Sci-fi teleportation is all about moving matter. But quantum teleportation, which, by the way, is a real thing we can do, is about moving information. You take the exact quantum state of a particle over here at point A, and using a cool trick called entanglement, you reconstruct a perfect identical copy over at point B. The original stuff doesn't travel. Its exact blueprint does. And this idea, transmitting a pattern instead of a physical thing, is absolutely crucial for what's coming next.
Okay, the second piece of our puzzle is a concept you've probably heard of, time dilation. Thanks to Einstein, we know that time isn't some constant universal clock. It's relative. If you put a clock on a spaceship zooming along at near the speed of light, it'll actually tick slower than a clock back here on Earth. Same thing if you put a clock near a black hole. This flexibility of time isn't just a theory, it's a proven fact. And that fact is the engine that's going to power our entire journey.
So what happens when we put these two wild ideas together? You get this, the Chrono Teleportation Gate, or CTG for short. This isn't our time machine. It's our map for navigating the landscape of space-time.
And this is where it gets really mind-bending. A normal quantum teleporter links two tiny particles. The CTG is a little more ambitious. The idea is to entangle the very fabric of space-time itself between two different locations. You're creating a stable quantum bridge. You're not just linking matter anymore. You're linking 2 points on the map.
So how in the world would a thing like this actually work? Let's pop the hood and take a look inside. The whole design really boils down to 3 incredible, though, yeah, highly theoretical pieces of tech, all working together in perfect harmony. First up, we have the Quantum Lattice Core, the QLC. You can think of this as the anchor point, or maybe the portal mouth for our space-time bridge. It's where the whole connection begins. So imagine this, a donut-shaped vacuum chamber, supercooled to almost absolute zero. Inside, it's humming along, generating and holding millions upon millions of entangled particle pairs in a perfectly stable field. Visually, it would be just incredible, a shimmering, glowing ring of blue-white plasma. Its entire job is to create and hold down one end of our quantum bridge. And of course, you'd need 2 of them, one for each end of the line. Okay, next we have the engine of this whole operation, the temporal field modulator, or TFM. If the QLC builds the bridge, the TFM is what actually twists that bridge through time. The TFM's whole purpose is to create a time difference between the 2 connected gates. How does it do that? Well, it uses time dilation. You could literally take one of your 2 gates, strap it to a rocket, accelerate it to almost the speed of light for a while, and then bring it back. Because of relativity, its internal clock would now be running behind the stationary gate. And just like that, you've created a temporal offset, a stable, measurable time gap between 2 points that are still quantumly linked. And finally, we need to make sure our bridge across time doesn't just, collapse. That's where the space-time phase stabilizer, the SPS, comes in. This thing is basically the guardian of the connection. I mean, just imagine the stress of linking 2 points in space-time where time itself is flowing at different speeds. The connection would want to just tear itself apart. The SPS acts like a shield. It uses this wild theoretical stuff called negative energy plasma, the same thing physicists think you'd need to prop open a wormhole, to smooth everything out and keep the corridor stable. This would create this beautiful, pulsing, aurora-like halo around the gate.
So let's do a quick recap. You've got the QLC, which is the anchor, using entangled qubits to make the link. Then you've got the TFM, the engine, using relativistic drift to create the time gap. And finally, the SPS, the shield, using negative energy plasma to keep the whole thing from falling apart. Anchor, engine, and shield, 3 parts working together to do the impossible.
All right, we've got the hardware all laid out. Now for the really fun part. How do you actually use this contraption to jump through time? Let's walk through the whole sequence, step by step.
The whole process happens in 4 key steps. First, initialization. You entangle 2 of those quantum lattice cores, creating the potential for a bridge. Second, you create the offset. The TFM does its thing and separates one of the gates in time. Third, you get a phase lock. The SPS fires up and stabilizes the bridge across that time gap. And only then, once the connection is secure, can you do the final step, teleport. An object's quantum pattern is scanned at gate A, sent across the bridge, and reassembled at gate B, in gate B's local time.
Let's make this real for a second. Imagine you have station alpha and station beta, and you've created a 48-hour offset between them, with beta being in the past relative to alpha. Okay, so at noon, the scientists at alpha teleport a test object. That object instantly appears at station beta, at noon, 2 days ago. Think about that. The logs at station beta would record the object's arrival before the logs at alpha even recorded that it was sent. That right there is reverse temporal displacement. Wild. So after all this crazy speculative engineering, what's the big takeaway? What does a model like this really tell us about the idea of time travel? It's this. This Chrono teleportation gate, it's not a ship that sails along the river of time. It's a bridge that connects 2 completely different points on the riverbank. You are just teleporting from one space-time coordinate to another one, where time is just another part of the address. You aren't traveling, you're relocating. Now, before we get too carried away, let's talk reality checks, because this model comes with some huge ones. For one, you couldn't travel back to before the first gate was ever turned on, which nicely sidesteps a lot of those pesky paradoxes. The energy needed to do this would be, well, astronomical. We're talking star-level power. The connection itself would probably be super fragile, with really short jump windows. And trying to teleport something as complex as a person without their pattern degrading into quantum static, that would be the challenge of a lifetime. And that really brings us to the final thought here. This whole concept completely reframes time. It's no longer just this relentless one-way street. It's a landscape, a dimension that we could, maybe, one day, navigate. It might be completely theoretical for now, but it makes you ask a really powerful question. If we could actually draw a map of space-time, what destinations would we choose to chart?